Section 3 just continues our study of inequalities, just like we continued our study of equations in Section 2. Section 1, again, was just sort of introducing what inequalities are, what they look like, how we graph them. Section 2 was solving inequalities with just addition or subtraction. And remember that we introduced what we called set builder notation. And I jumped ahead a little bit in the chapter for that, but that's okay. We can handle writing our answers in set builder notation now. It's just good practice. Section 3 involves solving inequalities using multiplication or division. Well, just like with solving equations using multiplication or division, as long as you multiply or divide both sides by the same number, you wind up with a true inequality, with the exception of one catch. There's a catch to multiplying and dividing when you're dealing with inequalities, and I'm going to show you that catch right now. So that's in this little blue box right here. On your note packet, the copier printed it really, really dark, so it's kind of hard to tell what's going on, but consider the inequality 4 is greater than 1. Is that true? 4 is greater than 1? Okay, so 4 is greater than 1. Then we're going to go through this table here, and notice on each side what's happening. We have 4 is greater than 1 to begin with. And now here we're going 4 times 3, 1 times 3. So we're multiplying both sides by 3. Then multiplying both sides by 2, multiplying both sides by 1, multiplying both sides by -1, multiplying both sides by -2, multiplying both sides by -3. Okay? So each time we're just decreasing the amount that we're multiplying by 1 each time. Okay? So 4 times 3 is what? 12. And 1 times 3 is 3. So we get 12 here, and we get 3 here. So what inequality symbol would I need to put in there? Greater than. 12 is greater than 3, so no surprise. 4 times 2 is 8. And then 1 times 2 is 2. So the inequality symbol I need there is still greater than. No surprise. 4 times 1 is 4. 1 times 1 is 1. And the symbol that we need there is greater than. Okay, so this probably seems pretty pointless. 4 times -1 is -4. 1 times -1 is -1. The symbol that I need there is less than. -4 is less than -1. 4 times -2 is -8. 1 times -2 is -2. The symbol I need there is less than. And finally, 4 times -3? -12. 1 times -3? -3. The symbol I need there is less than. So, to answer the question here, what happens to the inequality symbol when you multiply each side by a positive number? That's this part right here. If I'm multiplying by a positive number, what happens to the inequality symbol? What happens to it? It doesn't change. It stays the same. What happens to the inequality symbol when you multiply each side by a negative number? It flips. Yeah, it was greater than, it's now less than. Okay? So that's just by looking at this stuff here. I can do that with anything. I can take 2 is less than 5. True? Okay, now I'm going to multiply both sides times 3. And I get 6 is less than 15. Still true? Yeah. But now if I if I multiply both sides by -2, then on the left side I get -12. On the right side I get -30. And is -12 still less than -30? No, -12 is greater than -30, so I have to flip the inequality. So that's a rule that we're going to have to follow. That's the catch to multiplying, and really here in a little bit we'll see that dividing also happens the same way. If you multiply or divide by a negative number, the inequality symbol has to flip. That's not true for addition and subtraction. It's only true for multiplication and division. So that's the catch that you need to be watching for anytime you're multiplying or dividing. If it's a negative number, the inequality symbol flips. All right, so if you multiply or divide both sides by a positive number, the symbol, the inequality symbol, does what? If I multiply by a positive number, the inequality symbol stays the same. But if I multiply both sides by a negative number, this time the inequality symbol does what? No. No. It flips. If it was less than, it becomes greater than. If it was greater than or equal to, it becomes less than or equal to. You just flip the symbol. So, solve and graph each inequality. Just like if I'm trying to solve an equation, if this was an equal sign here, instead, what would I do? Multiply both sides by 3. Well, it's not an equal sign. It's an inequality symbol. So I can do exactly the same thing. I just got to watch out for this situation right here. So I'm still going to multiply both sides by 3. On the left side I get what? X. On the right side I get what? Negative 6. And my inequality symbol is going to, well, it's less than now. Did I multiply by a negative number? I multiplied both sides by a positive number. The inequality stays the same. It doesn't matter if this number over here is negative. The question is, did I multiply both sides by a negative number? And the answer is no, I didn't. That's a positive 3. So therefore the inequality symbol stays the same. It's still less than. We want to put that in set builder notation. So we'll draw our little such that bar and put an X there and then squiggly brackets. And now it's in set builder notation. We read that as X such that X is less than negative 6. X values such that X is less than negative 6. The directions say solve, we did, but also graph, so we still need to draw that number line. Get used to that. Pretty much every single problem that you do is going to ask you to draw a number line as well. So make it automatic. We need the negative 6 in the middle. We need a couple other numbers. So maybe negative 7 on the left and negative 5 on the right. It says X is less than negative 6, so we're going to what? Don't forget the dot. Open dot, and then we are going to go to the left for less than. Okay, let's go to the problem below. Negative 3/4 W is greater than or equal to 3. I want to get W by itself in one move, so what can I do? Multiply by the reciprocal, which would be negative 4/3. Okay, on the left side, negative 4/3 times negative 3/4 gives me just W. On the right side, we have 3 times negative 4/3, which gives me negative 4 is correct. And this time we are going to flip that symbol. It says greater than or equal to. This time we're going to write less than or equal to. And we're flipping it because this time we multiply both sides by a negative number. Negative 4/3 to both sides. So that inequality flips. We put that in set builder notation. We can do that right away because of the fact that our answer is written with the variable on the left already, so we didn't have to reverse it. And we still have to graph it. So I draw my number line. I need negative 4 in the middle, and then I'll put negative 5 over here. And then on the right, I'll put negative 3. And my graph will be what? Closed dot. And we're going which way? Less than is to the left. So there we go. There's the graph. All right, the other two are yours. How can I solve that top one in one move? Multiply both sides by 8. Okay, and on the left that gives me C. On the right that gives me 2, once you reduce it all down. And my inequality symbol will be the same. We didn't multiply by a negative, so the symbol stays the same. Set builder notation, put the such that bar in there. We have C values such that C is greater than 2. And then we need to graph it. Number line, we'll put 2 right in the middle, maybe 0 over here this time and 4 over there, just for something different. And the graph will be open dot and to the right. Greater than is to the right. There you go. Okay, the bottom one, what do? Multiply both sides by negative 3. Okay, on the left we get n. On the right we get positive 3. And then in the middle the symbol will be flipped. So it becomes greater than. We had to flip it that time because we multiplied both sides by a negative number. And we can put that in set builder notation. It's very easy. And then we draw our graph. Number line, 3. Maybe I'll put a 1 here and a 5 here. What do we got? Open dot and to the right. Because greater than is to the right. So that's it. That's how you multiply inequalities. All 4 of those problems were multiplication problems. We had to use the multiplication property of inequality to solve it. All 4 of these problems involve using the division property of inequality to solve. So if we take a look at this first problem, negative 9y is less than or equal to 63. How do I solve for y? Divide by negative 9. And when you do that, you get y on the left and what on the right? Negative 7. And my inequality symbol will be, we flip it, greater than or equal to negative 7. I can put that in set builder notation really quick. The directions are the same for these problems, even though you're on a different page. We still have to graph. Put our negative 7 down, and maybe negative 8 here, and negative 6 here. The graph will be closed dot and to the right. Greater than is to the right. Okay, go ahead and do the other 3. So I try to give you guys a variety of problems so that you see kind of how you can be tripped up. And there's a couple of problems on here that can definitely trip people up. So that's why they're on here. If we go across the negative 5x is greater than negative 10, if I want to solve this, I'm going to divide by negative 5 to both sides. That'll give me x here. That gives me what on the right? Positive 2. And then my inequality symbol will be less than. We have to flip it because we divided by a negative number. Okay, the variable is on the left, so I can put that in set builder notation very easily. X values such that x is less than 2. And I can draw the graph also very quickly. Put the 2 there, maybe a 1 here and a 3 here. Less than says open dot, and then to the left. So there's my graph. Okay, the next one, what do we do? So, yep, divide by negative 5 to both sides. On the left we get negative 4. On the right we get a. The symbol has to flip, that's right, because we divided by a negative number. So instead of greater than or equal to, it becomes less than or equal to. But now the a is on the wrong side. We need the a to be on the left. So that means I need to read this backwards. A is greater than or equal to negative 4. It's the same answer. It's not like we're flipping the inequality back. We're just reading it backwards and writing down what we read backwards. Now we can put that in set builder notation. And then we can draw our graph. Negative 4 here, and then maybe negative 5 here, and negative 3 here. The dot will be closed, and we're going greater than to the right. You have to have the variable on the left and the number on the right in order to be in set builder notation, and also to say that greater than is to the right. If the variable's on the other side, then the arrow will probably be pointing the wrong way for you. For the last one, what do we do? Divide both sides by 6. So on the left I get n, on the right I get 26ths, which reduces to 10/3. Stick with the fraction, please. You don't have to go to decimal. Just reduce the fraction. Okay, and the symbol will be, we divided by a positive number. It doesn't do anything to the symbol. It stays the same. That is already in the format we need, so I can make set builder notation right away, and then I can draw my graph. Now the question is, this is the hard part that trips people up. How do I show 10/3 on my number line? No, stick with the fraction. It's better, trust me. How about we just put a line right here and we call it 10/3? Okay? Now, to the right we need a number. Well, what is 9/3? 3. Then we have 10/3, so what's my next number over here going to be? 11/3, or if I keep going, 12/3, which would be 4. So 10/3 is between 3 and 4. For those of you who got the decimal of 10/3, you got 3.3 repeating, right? It's 3.3 repeating. 3.3 repeating is between 3 and 4. So I put a line over here and I call it 4. Okay? It's very easy to come up with those. Just think a little bit. All right, then we just got to put an open dot, and then less than says to the left. That's it. We got 2 more problems here, and then we're done with the section. Both are story problems, no big deal. You walk your dogs in the neighborhood after school. You earn $4.50 per dog. I might actually pay that, $4.50 per dog. You want to walk my dogs. Good luck. Yeah? One of them tore my shoulder out the other day. Anyway, you earn $4.50 per dog, and then it says, how many dogs do you need to walk? Well, how many dogs is your clue as to what the variable is. Remember, when we do story problems, the first thing we do is define the variable. The variable is how many dogs? Well, how many dogs is a number. So, number of dogs will be my variable, and what do you want to call it? D? Okay, fine. You call it X if you wanted to. D stands for dogs. That makes sense. All right, so now the problem tells me you earn $4.50 per dog. The per dog tells me that the variable is attached to the $4.50. Okay? So I'm just going to write what? $4.50 D. Then it says, how many dogs do you need to walk to earn at least $75? Greater than or equal to 75. There you go. That is the inequality. Now we just got to solve it. What do we do? Divide both sides by 4.5. And we're going to get D has to be what? Greater than or equal to or less than or equal to? We don't have to flip the symbol. We didn't divide by a negative number. So greater than or equal to what? It's 17? Okay. You got to walk my dog 17 times to earn $75. Or more, and then you'd earn more than $75. So to answer this problem now, since it's a story problem, we're going to write need to walk at least, since they said at least here, need to walk at least 17 dogs. And that answers the problem. There's no need to graph here. You answer the problem with a sentence. Good enough. So what's the first thing we should do? Define the variable. And the variable here is going to be what? You want to call it V for what? Vases? Oh, number of cases. So why V? Vegetables? Oh, okay. Or we could call it C for number of cases. I mean, it's cases. Or we call it X. It doesn't matter. Okay. So it says, what are the possible number of cases? So that tells you that the variable is the cases, number of cases. And let's call it C for cases. Okay? All right, we need to write an inequality. So we know that the cases cost $10.68 a pop. We can spend at most $50 for this project. So however much I spend, can it be more than 50 or less than 50? It has to be less than 50. Can it be exactly 50? Yeah, it can. Okay. So I'm going to write 50, and then my inequality here will be whatever I spend has to be less than or equal to 50. All right, so I have a variable of C. What is on the left side? $10.68 per case. Okay, so now we solve, which means we're going to and we get C is less than or equal to 4.68 cases. Now, what are we going to say there? You can't buy half a case, right? So it's either going to be 4 cases or 5 cases. If I buy 4 cases, I'm under $50. If I buy 5 cases, I'm over $50, and I can't do that. So my answer here has to be, what are the possible numbers of cases the club can buy? The club can buy at most, notice I'm using the same wording that they used, at most 4 cases. So for part B, it says in problem 3, why do you round to the greater whole number? You actually don't round to the greater whole number. That's a mistake. You round to the smaller whole number. Even though for rounding, you technically would normally round up. But in this problem, we can't round up because then we'll be over the budget. So we round to the smaller whole number because you can't buy half a case. You can't buy parts of a case, only whole cases, because we can only buy whole cases, and 5 cases cost too much. That's why. So you guys already understood all that, but we want to write that down to make sure that we know for sure. I could easily ask a test problem like that. Ask you a problem like this and expect you to be able to give me an answer that sounds like that. Okay? So it's not just like solving problems and writing down numbers. You've got to kind of explain things every now and then too. That's the whole section. You're able to do everything now.